Hi, welcome to Digital Dialogs, your compact conversations on the future of technology. My name is Renee from Reply, and today we're going to talk about enhancing human-robot collaboration through advanced interfaces. Quite a mouthful, I know, but it will surely be exciting because I have a very good special expert guest today, Jeff Delmerico. Hi, Jeff. How are you today?
Hi, Renee. I'm doing very well, thanks. And thanks so much for having me.
Awesome. Thanks for being here with us. First things first, like I always do with every guest, please introduce yourself to us. Tell us a little bit about your background as it relates to research and also the things you're doing right now.
Sure. So I got into robotics research during graduate school. I had previously studied physics and mathematics, but then I did my PhD in computer science at the State University of New York at Buffalo in the US. And my thesis focused on semantic mapping for ground robots. And after some time as a postdoc, in working on perception and navigation for first marine robots and then aerial robots. In 2018, I joined the Microsoft Mixed Reality and AI Lab in Zurich, Switzerland. And my role there as a senior scientist involves bringing autonomous agents like robots into our spatial AI ecosystem.
Awesome. Well, that's super exciting. Let's talk about it. Like, first of all, you might be able to explain how advanced interfaces like spatial computing or mixed reality can enhance human-robot interaction. Like, let's think about teleoperations, but there's much, much more beyond that. And they can also improve the spatial intelligence of robotic systems. So, can you tell us a little bit about that?
Definitely. So I'd say over the last 10 years, 15 years maybe, we've seen some really parallel developments in mobile robotics, but also mobile computing for humans. And a lot of that has been driven by visual simultaneous localization and mapping, or SLAM, which allows a device that has cameras mounted on it to track where the device is moving. And so many listeners probably use this already in AR or augmented reality enabled mobile phone apps. And it's essentially the same exact technology that many mobile robots are using in order to understand how they're moving through space and also understand what the space around them is like and what the environment contains. And so, because both types of devices, the kind of human-oriented mobile phones, and also this is fundamental technology for any head-mounted devices like mixed reality headsets. Um, that the human devices as well as the mobile robots are essentially solving the same problem, and so there's a natural synergy there to try to bring the spatial understanding that both types of devices develop on device to share that. And at least my work with Microsoft has been focused on doing this through the cloud, in having a shared map that lives in the cloud that both human devices, whether it's a Microsoft HoloLens or a mobile phone, and also mobile robots, can both use to navigate and understand where they are in the world. And if that's sort of a foundation for having a common spatial understanding for humans and robots, because if you have a map of the world, then your device can know where it is. You know, if you're looking at your phone, you often probably do this with through GPS when you're outside. But imagine if you're in an indoor environment and you want to know where your device is. Having a map of the indoor space that a cloud service can tell you where your device is allows you to understand far more information about where you are, and perhaps get indoor navigation to something, or see information about something that's in front of you. And robots can utilize exactly the same digital twin information, or some digital representation um, of the world. They can leverage the same information that we as humans can to do things better if we understand what's around us through our technology. That provides a way for robots to also understand the world in the same way. And mixed reality devices make this easy and intuitive. In particular, with head mounted displays, you can really see that representation overlaid, see those digital representations of the world overlaid on the world in front of you. And this is also possible with sort of a more limited experience, less immersive, with AR devices through your phone, where you can see through the screen digital content overlaid on the world. But with either of these, augmented or mixed reality types of experiences, you can see a blend of the digital and the real world. And um, and this is essentially what the robot can also see if it's standing in the same place. And we can use that shared spatial intelligence to do more than robots typically do in real world environments now. So instead of just working on an assembly line where they don't even move around, they just do the same repetitive task all day with high precision, or perhaps move things from A to B in a factory or a warehouse. Um, if the robot can understand its environment better, and can communicate, we can communicate spatial information from humans to robots and vice versa more easily, then we're able to generalize to other tasks, more complicated tasks, new environments. And as an example, a use case that we've worked on in my group at Microsoft is showing this kind of interface between mixed reality and robots through what we call mission planning. So essentially, that if in an inspection scenario, you want to tell your robot where in your facility it needs to go and inspect, take pictures, or gather other kinds of data to make sure that your machines or whatever are in a good state. And so one way to do this is to teach the robot how to do that by driving it around from place to place
Hmm.
with a joystick and walking right behind it. And that's certainly possible to do. That's actually how it's often done if the robot needs to do the same thing multiple times. And then the second time it can do it autonomously by itself. If we use mixed reality instead, the robot doesn't even need to be there. We can walk around with a HoloLens, what we did, or with any kind of mixed reality device. And while we are mapping the environment, we can also place waypoints where we want the robot to walk to, and then do its inspection. And when the robot needs to do this autonomously, we don't even have to do this in a teach and repeat type of scenario. We can just have the robot wake up, localize to the map we've created through mixed reality, and then the robot will understand where it is in the map, and also where are the goals that we've given it to navigate to, and to do its inspection. And so this is one simple use case of how we can leverage mixed reality to share that spatial information with robots in a way that makes it more efficient for both the human and the robot in that particular scenario.
Gotcha. So what you end up with in the end is when you have these kind of spatial understanding, this SLAM map, this spatial map captured with whatever device, and then you can transfer it also to other heterogeneous platforms that then share the same map. What you get is in the end a computer vision machine readable map of our world. In the end, if you scale it up to the whole world or a certain region, let's say a factory, right? You do all the scanning, if you want to call it like that, and then you have this machine readable computer vision map that you can share between all of these devices, and they can all co-locate. And that is amazing. And also, like you were saying, in the end, these robotics systems, these robotics platform have always a perception stack. Usually it's computer vision driven, and we don't see what these robots are seeing, if you will. But once we share the same spatial map and you have a head mounted device, you can actually see what they are seeing, if you will. I mean, I'm exaggerating a little bit, but you might call it X-ray goggles for robotics, right? So
Yes,
that's what you have. Like,
absolutely.
yeah, it's like in the old magazines where they say, "Oh, here's X-ray goggles, 50 cent or whatever it was like."
Yes.
And now we get like a much more expensive, though, but much more powerful and useful X-ray goggles for robotics. Obviously, that's a simplification massively. And you also alluded to one important aspect is it this works since this is computer vision based. This is visual positioning system that also works indoors because the GPS, the global positioning system, we all use every day pretty much. That depends on satellites, and so it only works outdoors. And this system with VPS works also indoors, and also I think it's higher precision, isn't it?
Yes. So we can get, let's say centimeter level accuracy in localization. So it's maybe not precise enough for some, let's say, construction tasks to make sure that a robot drills a hole in exactly the right space. But as far as the human experience of localizing to one of these maps with a mixed reality device or a mobile device, it's very easy to understand your position, even if you're 10 centimeters off in one direction or another. And this is also not a problem for mobile robots because, in addition to providing or to having a kind of global um, localization to one of our maps, almost all robots are going to be doing their own local mapping and obstacle avoidance, so that they don't trust the position we tell them. They also make sure they don't run into anything that maybe isn't represented in the map. And so because of this, the accuracy has so far in the work that we've done been very adequate for any of the type of collaborative tasks that we've explored. And so I anticipate that with continued research in this area, it will also get better in the future.
Gotcha. You already talked a little bit about it before, but I can imagine this is a very hard problem to solve because there's a lot of components involved. You have massive amount of data, you have lots of integrations and so on. And maybe you can talk a bit about it. What are some of the key challenges, but also opportunities in integrating all of these spatial computing interfaces in robotics and how they would transform our human robot collaboration?
Yes, definitely. So, I mean, I think one of the biggest challenges in this space, in terms of the devices that we use as humans to do these kinds of interactions, it's really form factor. Mobile phones are ubiquitous. Everybody, especially in many modern workplaces, have a phone that they use as part of their workflow in the tasks that they do. If they're frontline workers or information workers, they're likely using a mobile device in some aspect of their work. And so those are they're very they phones are all over in the market and in every industry, and so that's a real positive. But at the same time, the AR experience is a bit limited, and they're not always in hand. Or when you need to use one, it's not hands free. Um, Head mounted devices, on the other hand, like Microsoft HoloLens or quite a few new smart glasses type devices, they give you a more immersive mixed reality experience, but there's not really widespread adoption. Certainly not, it's orders of magnitude different from what we have with mobile phones. Um, and But I see this challenge also as an opportunity that there's so much space for progress and opportunities to drive new types of devices in the future. Maybe not even the kind of things we're imagining, like phones or something on your head. They might be entirely different types of wearable computing. And we've actually, in last couple of years, seen a few things pop up in that direction. And maybe that didn't have spatial understanding, but that are new ideas about how we can have computing move with us through the world. So I'd say the form factor thing is still there's still a lot of development to go there. I would say another thing that's a challenge, which you alluded to a minute ago, is that having robots work safely in shared environments is not something that is fully solved yet. In many workplaces, your robots and humans are kind of segregated into different spaces, so that there's not really an opportunity for humans to be injured by robots. Or if they share the same space, and robots are overly cautious about humans, they will stop and wait for an overly long time until they definitely sense nothing is nearby before they start to move again. And um, and I think that's a great opportunity for the advantage of mixed reality that you mentioned, which is being able to see the intent that robots are what they're planning to do. That's something that's very difficult to communicate. If you're looking at a robot and it's driving towards you, even with some turn signals on it or something like that, it's kind of hard to tell what it plans to do. Um, and mixed reality, having that shared spatial intelligence, um, and a shared representation of the world would allow the robot um, to share with anyone nearby, like, hey, I'm gonna drive in this direction. And humans are very good with social compliance. If you're walking down a crowded sidewalk, you know how to avoid people that are walking towards you. We can leverage that if we see what the robot's planning to do and walk around it without there needing to be such cautious behavior from the robots, and also without needing to without needing to keep robots and humans separate. That's an easy way that we can both share our intent with the other parties. And I'd say a final challenge I want to mention is robot adoption in the real world. So, in many industries, there are more and more robots every year automating all kinds of different tasks. Um, but despite all the advances in perception and navigation and more manipulation, most of the work that gets done by robots in the real world is kind of pretty limited to simple tasks. So moving things from A to B or working on an assembly line. Um, and they don't really require a lot of spatial understanding to do most of those things. But many robots are navigating with a magnetic strip on the floor, so they just drive a loop. They don't really need to understand where anything else is or uh, what the rest of the environment looks like. And the opportunity here with robot adoption is that although robots now do what they're good at and humans do what they're good at, if we can get to a point where robots are more cost effective and efficient to use in more capable robots are more cost effective and efficient to use in these kinds of commercial and industrial settings, then we'll need a way for non-roboticists and frontline workers to be able to work alongside them and program them without necessarily, writing computer programs. And doing that kind of collaboration on tasks or working as partners in a workplace, I think mixed reality will be a real key technology in making that kind of experience or that kind of workplace really intuitive for everyone.
Yeah. Yeah. That makes a lot of sense. Also, like what you said about these days, a lot of these robotic systems, when they're deployed, they're segregated from the human workforce, and the full integration is actually what is needed. But this also needs to happen in a safe way, which could be a challenge. But like having the shared map and also leveraging mixed reality definitely can improve that. I totally see your point there, and I also think that one of the later points you said is also in particular interesting. I also think generative AI might play a bigger role for these kind of future systems. But maybe you can also talk a little bit what you think the future, what you envision for the future of these human robot interfaces. Like, what will happen there?
Sure. Yeah, I mean, I think, right now we can see a glimpse of the future in the research domain. I think a lot of the good examples of human robot collaboration, where robots are starting to be able to contribute to the collaboration with humans, where it's maybe becoming on par with having two humans do a task. If you can have a human and robot leverage their own strengths to do something, most of that is still in the academic research domain or corporate research domain, and not really um, showing up in workplaces. But I think as robots become more capable and our interfaces become more advanced, I think we'll really see a rapid inflection point um, in this area. And when it comes to the actual interfaces, I mean, I think that the North Star across the mixed reality industry is really something close to eyeglasses as a form factor, because that's something you could imagine wearing all day. And we're still quite a long way from having this sort of battery tech and display tech to make that a reality. But if you had a device form factor that was as easy for everyone to use as mobile phones, um, then you'd start to be able to have the benefits of the immersive experiences of head-mounted displays with with the accessibility that we have now with mobile phones. And I'm encouraged by the developments that I see in that direction. I mean, I think not just at Microsoft, but in a bunch of other players in the tech industry. Um, I think they're all interested in having on some level, everybody wants to develop the next iPhone that's really going to just be a disruptive transformation in how people use technology in their day to day life, and and so I think there are exciting things ahead in that direction, and what form the wearable computing will take. Um, but there's there are also a lot of remaining challenges between kind of where we're at with um, robots and humans being able to just understand the world together. Um, there's a lot of work yet to be done in in making softer, more compliant robots that if they're working alongside humans will be it'll be more difficult for people to be injured by them. Um, for AI to kind of translate human requests in natural language into tasks that robots can execute, so that anybody who's working alongside a robot can tell it what to do without needing to be a roboticist, and also better manipulation hardware and software to be able to make interaction with the real world more dexterous and more make robots capable of not just observing the world with their sensors, but also interacting with it, because that's where you can really begin to have robots um, uh, do more effective tasks and really contribute to things collaboratively with humans. Um, but I think to close, I would say I think we're already really rapidly moving in that direction. Um, every year, there's lots of new robots on the market that are automating many different tasks. Often, these are things that are challenging for humans or dangerous for humans in industries like construction or inspection in factories, cleaning in hospitals. Um, and these are mobile robots that maybe they have a kind of specific function, um, but they're already crossing that threshold into more general environments. And I think in addition to being able to deploy robots to new places, I think getting them to also generalize to new tasks is really going to be the key. Um, and I think a lot of that will be being able to work with them as humans, and so mixed reality is going to be a real key key point of that, or let's say spatial, more broadly, spatial AI, spatial computing will be a real key factor in that.
Totally. I couldn't agree more. It's like the shard map is just the beginning, and the next steps are going to be intense. I think also with generative AI, thinking about natural language as the interface. Basically, you can just talk in your natural language. You don't have to program like every step and so on. Yeah, truly interesting things. And we could talk for much longer, but we try to keep these podcast episodes short and on point. And you did very well. So thank you for so much, Jeff, for sharing your insights today.
You're
That
welcome. It
was
was my pleasure.
awesome. Well, and thanks everyone for joining us today for Digital Dialogues, your compact conversations on the future of tech. Watch our blog, follow our social media, and subscribe to the Reply podcast channel on your favorite podcast platform. We're available on all the different podcast platforms that you probably might be aware of. And of course, you can always go to our website at reply.com to also listen to the latest episode and also the previous episodes and also the other podcasts we're doing. So check this out. Until then, take care and see you soon. Bye bye.